Lesson 2, Organizing the Project. In this lesson, we will cover project libraries, the Project Explorer, and how to resolve conflicts in a LabVIEW project. A project library is a collection of VIs, type definitions, shared variables, and other files that are related together to form a cohesive unit. Project libraries contain a two-way link to all of the VIs that are contained within them. Files that a project library owns still appear individually on disk in the directories where you saved them, but there is a two-way link between the project library file, .lvlib, and the member files. In other words, a project library stores information about which files are members, and each member file stores information about which project library it belongs to. If either of these links are broken, the VI will display a broken run arrow. Benefits of using project libraries include the following: organizing related files into a shared hierarchy to ensure that they are distributed together, avoiding potential VI name duplications by adding a qualifier to the VI name as shown here, and modifying the access scope of certain files. Using project libraries. Create a separate directory on disk for each project library. This directory should contain only files that are library members. Save the project library LVLIB file in the same directory as its members. These are the only files that should be in that directory. Each project library knows the path to each of its members, and each member knows that it is part of a project library. In this demonstration, we will cover LabVIEW Libraries. To create a library, right-click on a target in the project and select New Library. Save this library file in a new folder on disk. To add files to a library, right-click and select New or Add VI. Save this VI in the same location as the library. I'm now going to create another VI that calls my method VI from my library. This VI will not be part of the library and will just exist under my computer. Note that I'm saving it in the project directory rather than the library directory. I'm going to have the caller VI call the method VI from my library. Notice the difference in the icons between the method VI inside the library and the regular VI outside the library. Notice that caller VI is executable and runs just fine. I'm now going to change the access scope of the method VI to private. Notice that this breaks the run arrow on the caller VI. Privately scoped VIs can only be called by members of the same library. To fix this broken run arrow, I'm going to move caller VI into my library. Caveats when using project libraries. Each project library knows the relative path to each of its members. What this means is if you rename a member on disk or move a member VI to another location, the library will not be able to find the file and the VI will be broken. If you move the project library will not be able to find any of its member files and all of its member VIs will be broken. Additionally, each member file knows that it is part of a project library. If you delete or move the project library, the VI will break. Remember, best practices for a library are to store the library and all of its member VIs in the same location on disk with nothing else in that directory.
A member of your development team, with the help of a boiler expert, created a software model for the boiler that your application will control. To simplify distribution of these files among your development team, you decide to create a project library. However, not every member of that library should be accessible outside of the library. To control what VIs are able to access these members, you must set the access scope for any items that you want to be private to that library. In this exercise, you will create a project library and configure the access scope for its members. Let's take a look at the solution to exercise 2-1. From this folder, we'll open boiler.lvlib. When we do so, we can see the library that we created and the files that the other developer provided to us. You can see that some of these are marked with red keys. The items with red keys next to them are privately scoped controls and VIs. That means that they can only be used by other VIs and controls that are members of this library. Items without keys can be used by VIs and controls outside of the library. For example, if I create a new VI and then I drag boiler configuration.ctl onto the front panel, no problem. There's a runnable arrow, everything looks good. However, if we go over to boiler UI data, which is a private control, and drag it over to this front panel, we see that we break the VI and it's not runnable. That's because this VI is not a member of the library and thus doesn't have privileges to use those privately scoped items. Project libraries are useful for ensuring that VIs are not distributed or used without the sub-VIs and custom controls that they require. If you need to limit how member VIs and controls are used, project libraries let you assign an access scope to individual items.
In this demonstration, we'll go through some of the tools available in the project. The first is going to be find callers and find sub-VIs. I'm able to right-click on any VI in the project and select Find Callers or Find Sub-VIs to generate a list of all of the callers or sub-VIs for the respective VI. In this example, caller is calling method, and untitled one is calling caller and method. No items are found for sub-VIs because method has no sub-VIs. Two callers are found because method is called in both caller and untitled. Double-clicking on this will bring me to that item in the project. I can also search the project for items by name. The Show Item Paths or Files view can be useful for determining where items are on disk. Crosslinking and conflicts. Crosslinking occurs when a VI calls a sub-VI from an unexpected location. You've probably seen this warning dialog box before. This is telling you that a VI has loaded a sub-VI from an unexpected location. This generally happens after you've copied or moved files around on disk. Usually this is not a problem and it is safe to ignore these warnings. However, when two VIs with the same qualified name are loaded into the project from different locations on disk, this will result in a conflict. Here we have two examples of conflicts. The first involves the generate signal VIs. Note that one is in the sine wave directory and the other is in the square wave directory. Since both of these VIs have the same qualified name, a conflict occurs. We can resolve this conflict in two ways. The first is giving each VI a unique name, such as generate sine signal or generate square signal. The alternative is to add each of these files to their own project library. The second conflict is slightly more complicated, as it involves two different versions of the same log-to-file VI being loaded from different directories on disk. In this case, one of the VIs in the project has loaded the log-to-file VI from the backup directory rather than from the working directory. While renaming the VI will resolve the conflict, it will result in problems later on, as you now have two copies of the same VI with different names. Recall that conflicts occur when two VIs in the project have the same qualified name. Resolving conflicts is as simple as giving a unique name to each VI in the project. However, it is important to know which VI on disk you are calling. For example, our generate signal VI has two implementations, generate sine wave and generate square wave. If we decide to change the name of these VIs, we need to make sure that the square wave implementation of generate signal is renamed to generate square wave. To ensure that you are selecting the correct VI, you can use the Files view, Show Item Paths, and Find Callers or Find Sub-VIs functions that we discussed earlier. For cases when you have a single VI loaded from multiple locations on disk, such as the log to file example, you can use the Resolve Project Conflicts dialog box to select the correct VI. The Resolve Project Conflicts dialog box is a useful tool that will help us resolve conflicts like our log to file conflict where we were loading the same VI from two different locations on disk. Note that we are loading one from the working directory and one from the backup directory. If we select the working directory log to file and click the Use Selected item, it will replace all of the log to file instances in the project with this copy. It's important to note that the Resolve Project Conflicts dialog box will not help us resolve the generate signal conflict that we discussed earlier. If we were to select either of these generate signal VIs, every generate signal VI in the project would be replaced with either the square wave or the sine wave implementation. You have completed this lesson. Here's a summary of what we covered.